Hi, this is Mr. Precella, and that's the other Mr. Precella, and today we're going to be discussing how to solve absolute value equations.
It'll be much easier than the last assignment. We promised y'all that, and I'm sure you'll agree with me by the time we're finished. Okay, well...
And I think you've seen this enough, so I will close that up, and let's keep going.
Okay. I think all of y'all have heard of absolute value. I remember hearing the phrase in elementary school when I was
middle school. Negative numbers.
Yeah, I guess you're right. Middle school with negative numbers. But anyway, these vertical bars that I'm drawing represent absolute value. And we say the absolute value of a number n. Basically, for our purposes, it's a distance measuring device. The absolute value of n is the distance from 0 to the number n on a number line. We're just measuring the distance. For example, let's say, I'm going to draw a number line first.
Since you're saying the word distance, we assume distance is never negative. If someone asked you, what's the distance from here to your house, and you said, -7 miles, what the heck does that mean? Okay? Distance is never negative.
Okay, and looking at a number line, remember that assuming 0 is right there in the center, to the right are the positive numbers, to the left are the negative numbers. Suppose I wanted the absolute value of 3. I want the absolute value of 3. That's asking how many units is it from 0 to 3 on a number line? It should be obvious. 1, 2, 3 units. Suppose we had the absolute value of -3. How many units is -3 from 0 on the number line? Still just 3 units. Well, 1 is to the left and 1 is to the right, but we're just counting the number of units. From 0 to that number, it's still 3. Okay, here's one. What about the absolute value of 0? How far is 0 from 0 on the number line? 0, okay. So let me see. Let me try this. Let's see what's going to happen there. Okay. How about, I think we could, here. Before we state a rule, let's do one more. Whether we have a positive, whether we're looking at positive or -4, it doesn't matter. Whether you're looking at -4 or +4, what is the distance of those two numbers from 0 on the number line? 4, so I think we can convince ourselves whether the stuff inside there is positive or negative. Once you take the absolute value, what sign is it going to have? A positive number. And so we could say, in general, the absolute value, whether it's positive or negative n, it's just going to be that number n.
In fact, why not stick a plus in front of it?
Oh, okay.
To say positive.
Positive, that's no plus. Okay, here's my question. If we take the absolute value of 3, we get a positive 3. If we take the absolute value of -3, we still get a positive 3. Here's my question. What can I put inside these absolute value bars so that I get an absolute value of -3? Is that going to happen? No. The absolute value of nothing. If I wanted a -3 there, I'd have to have the negative stuck in front of the absolute value over here. I'd have to have a negative there and then just carry it over. we're going to look at 3 specific cases with regard to solving absolute value equations. So drop that down. Okay, I'm going to say absolute value equations. I'm going to lift it up. And case 1. Case 1 is going to go back to this this line I have right here involving 3 and negative 3. If we have the absolute value by itself, the absolute value by itself on one side equaling a positive number on the other side. Once again, the absolute value is by itself over here. If it equals a positive number, that means there are 2 possibilities. Either the stuff inside here, inside the absolute value bars, is equal to the positive of n, or the stuff inside there is equal to negative n. What can I take the absolute value of and get 4? Well, we said right here it would be positive 4 or negative 4. And this case 1 is the most common situation we'll see with regard to absolute value equations. The second case, the absolute value by itself on one side, the absolute value equals 0. The only way an absolute value is going to equal 0 is if that stuff inside there is what? 0. So that means the stuff inside the absolute value bars must equal 0. Third and final case, case 3. If we have an absolute value by itself on one side and a negative number on the other side. If you have an absolute value by itself on one side and a negative number on the other side, is that ever going to happen? It doesn't matter what you have inside there. When you take that absolute value, you're not going to get a negative number. I'll say has no solution. And let's look at a problem from the homework.
How about just first make up the example?
Okay, here's
the value of x
okay.
is 7.
I guess I've written down here. That's short enough.
So they can look at the 3 cases.
Suppose you have the absolute value of x is equal to a positive 7.
What are the only 2 numbers x could equal? Only 2 numbers that could be inside here.
Okay.
Negative 7 and positive 7.
So the stuff inside the absolute value has to either equal positive 7 or negative 7.
And you could have just written plus minus.
I could have, yes. And there's a hot button there available if you need it in the assignment. There's one other one I want to make up.
Oh, okay.
Before we start doing the homework. Let's say you have the absolute value of x plus 2 minus 5 is equal to negative 1.
This is an equation. Equations have equal signs, and it has absolute value bars. So the terminology, you can impress people if you know the right terminology. This is an absolute value equation.
The common mistake here is for people to see the absolute value equaling a negative number. And they think to themselves, well, it's case number 3. There's no solution. Think about how I was reading this out as I was writing it down. I'd say you have an absolute value by itself on one side, a positive number on the other. You have absolute value by itself on one side, 0 on the other. Here, an absolute value on one side, a negative number on the other. My point is, before you can decide which case you have, you need to make sure that your absolute value is by itself. Here the absolute value was by itself. But here, is the absolute value by itself? I think we have a -5 there. We need to get rid of that -5. What can we do to get rid of that -5 so that the absolute value is by itself? Okay, so we're going to add 5. So we'll have the absolute value of x plus 2 is equal to -1 plus 5 gives me a +4. Now you can look and decide which case you have. You have to have the absolute value by itself. What?
Oh, nothing.
You have to have the absolute value by itself on one side. Then you look at the number on the other side. Which case do we have of the 3 possibilities? Case 1, case 2, or case 3? Case 1, the absolute value is by itself on one side, a positive number on the other side. That means the stuff inside the parentheses, x plus 2, has to equal a +4, or x plus 2 is equal to a -4. And we know how to solve these two equations. What we do is solve this equation. Subtract 2 to give us x equals 4 minus 2 is 2. There's one of the solutions. Here, minus 2 to give you -4 minus 2 is a -6 for the other solution. Realize here we have 2 distinct solutions, but they're not just the same number with opposite signs. Here you have a +2 and a -6.
And you can logic your way through this by checking. If you put a 2 inside here for x, you have a +4 in the absolute value bars. The absolute value of 4 is 4. If we put a -6 in for x, what number would we have inside there? -6 plus 2 is -4, which has an absolute value of 4. Okay? Now, why don't we go ahead and write out the statement, always isolate the absolute value bars first.
Always isolate the absolute value bar. I'll just say always isolate the absolute value before solving. So let's look at number 1 in the homework.
Oh, let me see. Hopefully it hasn't logged us out. Okay. Oh wow.
Well,
Okay.
I think y'all can just tell us the answer here.
What is it? Only 2 numbers that could be inside. Positive or -7. Okay? So I'll click right here. By the way, this the second option B, that's what you would put if there were no solution.
Say that 7 had been a -7.
Mm-hmm.
Okay.
Sometimes students say, wait, it didn't give me the plus minus. You've got to click in the box before it shows you the tools. Okay? And then, okay, there's the plus minus 7. Or if you want to type 7, -7, it'll take that too. Okay, they can't all be that easy, so let's see the next one. Oh, well.
After our discussion, I think we all can tell me what that's going to be. No.
B. The number on the right is negative.
Let's write that down.
Oh, let's write that down. Okay.
Okay, this is number 2. We have the absolute value of x equals a -17. it doesn't matter what you put in here. When you take that absolute value, what sign are you going to get? Positive. This is that third case. The absolute value by itself on one side equaling a negative number on the other side. That is no solution. But Pearson has a select empty set because they don't give a no solution option. Any questions on our logic there?
You'll see the difference between problem 1 and 2. What's the difference? And don't say one has a 7 and one has a 17. The big difference is on the right, on number 1, it's a positive number. And on number 2, it's a negative number. Okay?
Number 3.
It can't all be that easy. Oh.
We have an absolute value of x minus 3 is equal to 19.
Here's how my logic, and this is the logic you're using too. Well, there's a positive number there. Oops, wait, let me flip over what you're going to say. There's a positive number here, so you're thinking to yourself, what are the only two numbers that can be inside here? What two numbers have absolute value equal to 19? 19 or negative 19.
This thing inside there has to reduce to 19 or negative 19. So x minus 3 has to equal positive 19 or has to equal negative 19. To solve this first equation, we add the 3. Okay, be careful. Undoing the minus 3, we add 3 to give us x equals 22. I agree. Here, we have that minus 3, so we're going to have to add 3 again. What's that going to give us? Negative 19 plus 3, I agree, with negative 16. So my two solutions are 22 and negative 16. Any questions there? A word of warning. The absolute value of A minus B does not equal the absolute value of A plus the absolute value of B. That x minus 3, it's staying at x minus 3. You don't just go through and change the negative signs that are within the absolute value. Notice that x minus 3, I still work with x minus 3. 22 minus 3 is 19. The absolute value of 19 is 19. Negative 16 minus 3 is a negative 19. The absolute value of negative 19 is still positive 19.
Okay.
Number 4.
Okay, wait. 22 and negative 16. I got a 22, comma, negative 16. Check it. Wow, we're just flying through these.
I have some other stuff I want to do after
we're
through with this assignment, so
yeah,
I don't have to worry. It won't be done too early or too quickly. The absolute value of 4x minus 3 is equal to 8.
Is this one that's going to be no solution?
No, we have the absolute value by itself on one side. What sort of number on the other side?
Positive or negative?
Which
Positive.
case? Case 1, 2, or 3?
Case 1.
Now, as I said, remember, case 1 is the most common. That is the most common scenario. Absolute value by itself on one side, a positive number on the other. So 4x minus 3 equals positive 8, or 4x minus 3 is equal to negative 8.
What you're doing is equal positive, equal negative. That's the formal name.
I don't know about that. Okay. What are we going to do first to solve this? I was about to do it. I'll let y'all tell me. Add 3. I agree. So we're going to have 4x. 8 plus 3 is 11. And then
only one thing left to do, just
divide by 4 to give us x equals 11 fourths. Here, add 3 to give us 4x equals, we're adding the 3 to give us 4x equals, negative 8 plus 3 is negative 5, and then divide by 4 again to give us x equals negative 5 fourths for my second solution. So we have two solutions, 11 fourths and negative 5 fourths. Any questions there?
notice both of these equations are linear equations, so you're just isolating the x after you go equal positive, equal negative.
Also notice that 4x minus 3, I remember the old multiple choice test. Invariably, for a question like this, the distractors are the wrong answers. The program would go through. Okay, pretend someone made that a plus 3 and solved it. What answers would they get? And invariably half the class would choose them, so the wrong answers. But those signs inside the absolute value, the only way that sign changes is if it's just a number by itself. Like right there. The absolute value of negative 3, that changed to a positive 3. But operations like minus do not change to plus. I guess until you start solving it. Mm-hmm. Any questions there?
So let me type that in so that y'all know it's right. 11 over 4 and negative 5 over 4. 11 over 4, right arrow, comma, negative 5 over 4.
Mm-hmm.
Mm-hmm.
And if you put the negative 5 on top of that fraction, it's just as right.
Mm-hmm.
So if you put the negative up on top. Okay. Oh, I guess I think I have room down here. Number 5. Let me move something. Hold on. No. Okay, now let's try. Okay. I forgot what the problem was now. I know there was an absolute value, and it was a 7x. Okay. 7x.
Minus 9 equals 40.
To try to stop that from looking like 17x, you'll notice what I'm trying to do, although it may be hard to tell. I'm trying to put those absolute value bars in a different color from the stuff inside there, so it doesn't look like a 14x minus 31. Okay? There's only one correct first step here. What is it?
Pull this down. And you know what? I'm going to use exponents. Here's a use for exponents. That little rule there, always, always, always isolate the absolute value bars before trying to solve the equation.
So with that in mind, what do we have to do? There's only one. Not 1. Add 9. Okay. So adding the 9. Once you do that, that's going to become the absolute value of 7x is equal to 40 plus 9 is 49. Now I claim this is case 1. We have an absolute value by itself on one side. We have a positive number on the other side. That means that step there, 7x, has to equal either positive 49 or negative 49. Solving the first equation to give us x equals 49 divided by 7 gives me a positive 7. Here, divide by 7 again. And what's that going to give me? Negative 7. 49 divided by 7 is 7. So in this case, we have a positive 7 and a negative 7. Any questions there?
So the answer for the one on the right, the negative 49 minus 7 is the value of the
It's a negative divided by positive is negative. 49 divided by 7 is still 7.
You've got to always get that by itself first before you can go equal positive or equal negative or to figure out which case it is. Okay?
And then you get the absolute value by itself, then you set up the cases without the absolute value bars, and then you get the x by itself. But that's true for any equation. If you're solving an equation, you want the x by itself. That's your goal in solving an equation.
Let's see, I'll say plus minus 7. Well, if you want to say 7 comma negative 7, it's the same thing.
Okay. Now number 6.
Don't panic too much.
Number 6. We have the absolute value of 2x minus 1 all over 3 is equal to 7. Okay. Are we going to have to move terms around the way we did the last time, or is this an acceptable form in terms of the case 1, 2, or 3? We're going to get rid of the fraction, but we're not going to do that until we've set up that we've determined which case we're looking at.
Are the absolute value bars by themselves? Yes. And what number do we have on the right? Positive or negative? It's positive. So this is case 1. And lowest.
So we have 2x. So this step inside here, it's going to have to equal either 7 or negative 7. That's the only way you're going to get an absolute value equaling 7 is for the step there to equal 7 or negative 7. So 2x minus 1 all over 3 is equal to positive 7, or 2x minus 1 over 3 is equal to negative 7. We're going to have to get rid of the fractions. Let's just solve this first one. The one with the positive 7. What do y'all want to do? I can think of 2 different approaches to eliminate those fractions.
Multiply both sides by 3.
So multiply by 3. 3 over 1 times 3. The 3's cancel. So you have a 2x minus 1 is equal to 7 times 3 is 21. I could add 1 to both sides to get 2x equals 22. Divide both sides by 2. So here's my first solution. x equals positive 11. Now, I'm going to remind y'all of something. I'll give you a moment to finish that. Once again, there's only one denominator here, 3, so what would be the least common denominator to multiply 3 by? It'd still be a 3, but remember, we could cross multiply if we wanted, and I want to remind y'all of cross multiplying. So I'm going to think of that as negative 7 over a positive 1. Do I remember cross multiplying? You can only do that when you have fraction equals fraction. So you go 2x minus 1 times 1, that's easy. 2x minus 1 times 1 gives me 2x minus 1. Then negative 7 times 3 gives me negative 21. If we had just multiplied by 3 on both sides, we'd still be at the same step. And then what will I do? Add 1 to give me 2x equals negative 21 plus 1 is negative 20. And I divide by 2 to give me x equals negative 20 divided by positive 2 gives me negative 10.
Absolute value bars were isolated or were by themselves. So you just go equal, and you have a positive number on the right. So equal positive, equal negative. So 11 and negative 10. Let me type that in. 11, comma, negative 10. Any questions? Well, here's the last one. So it's got to be the hardest one, right?
We have the absolute value of m plus 3 plus 6 is equal to 19. This sort of reminds me of that one that I made up at the start of class.
Oh, wait. Let me flip over that.
So I think we already know what we're going to have to do. Do y'all remember this one?
And then that rule.
Always isolate the absolute value before solving. So we had to get rid of that minus 5 there. Likewise, y'all tell me what I'm going to do here. Subtract the 6. Okay. So that gives us the absolute value of m plus 3 is equal to 19 minus 6 is 13. And now, it's a case 1 problem. We have an absolute value by itself on one side, positive number on the other side, so that m plus 3 has to equal 13 or negative 13. So m plus 3 equals 13 or negative 13. Subtracting 3 here, we get m equals 13 minus 3 is 10. I agree. There's my first solution. Here, okay, negative 13 minus 3 gives me a negative 16 for my second solution.
So 10 and negative 16.
And
You know what? Why don't we reverse this 6 and the 19. I'll redo that. 10 and negative 16. Okay. Let's make just a small change to that problem and see how that affects it.
Suppose the problem had said the absolute value of m plus 3 plus 19 is equal to 6. All we did was just reverse those numbers there.
How is that going to change stuff?
It's going to be a huge change. What do we have to do first? Isolate that absolute value by subtracting 19. So we have the absolute value of m plus 3 is equal to negative 13. What do we conclude? No solution. This is a case 3 situation. We have the absolute value on one side, a negative number on the other side, no solution. It doesn't matter what you plug in. You can plug in negative 50 million here for x. When you take the absolute value of it, the result will be positive, not negative. Any questions there?
So you can't just look at it and decide if it's case 1 or case 3 unless you have the absolute value bars by themselves. Like up here, there's not a single minus anywhere. But it's still a no solution one. Once you move that 19 over, then you have that negative on the right. Okay?
Okay. This pops up, something like this pops up in the next homework assignment as part of a bigger problem, okay? We're going to run into, okay, let me see. This is an example.
Here's an example.
Let me just write it down. Solve for x. The absolute value of x squared plus 2x minus 19 is equal to 16. X squared plus 2x minus 19 is equal to 16. This is a quadratic absolute value equation. Notice we have that x squared there.
All the other ones we've been doing today have been linear, no exponents in them. So that's how this one differs. There's that x squared. But is this a case 1? The absolute values are by themselves. We have what number on the right? Positive and negative. Positive.
So this is a case 1 equation. There are going to be two possibilities. You have that x squared plus 2x minus 19. The stuff inside the absolute value bar has to equal positive 16, or the stuff inside the absolute value bar has to equal negative 16.
So we're now reviewing how to solve a quadratic equation. Well, if we're going to solve a quadratic equation, we need it in that standard form. What number do I need on the right instead of a 16? 0.
So we'll subtract 16. And that'll give me an x squared plus 2x. Negative 19 minus 16, is that a minus 35? Equals 0. This isn't that bad. It's a simple trinomial. I think we can factor this. And the reason I'm confident it can be factored is because I've already factored it in my head, but also because they didn't say use the quadratic formula. Well, I made the problem up myself. I would have said.
But they'll see it in the next assignment, and there's no discussion of quadratic formula.
X squared, x times x. What do we know about the signs? Okay, the last sign's a minus, so you have one of each sign, a plus and a minus. Now 35 isn't that bad. 1 times 35 or 5 times 7. That's it. Which pair do you want to use? With a simple trinomial, you choose the pair, in this case, that subtracts to give you a 2. So play it out in your head. To get a positive 2x back, we have a 5 and we have a 7. What sign should I have here between the x and the 5 in order to get back a plus 2x? Okay, so the negative here, the positive there. I agree. Do y'all agree with that? The outer product, x times 7, that's a 7x. What's the inner product? 7x minus 5x. That's a positive 2x. Is that what we needed?
Mm-hmm.
Yes, it is. Set each factor equal to 0 to give us. First, here,
Positive 5.
and negative 7. Okay. So at this point, we have positive 5 and negative 7 as solutions.
Come over here.
Now we're looking at the second possibility. What do you think we need to do first? There's really only one correct next step. Add 16. We want to get that equals 0. Oh, I think this one's going to be a little cleaner. So we have x squared plus 2x. Negative 19 plus 16 is a minus 3. And it's another simple trinomial. Notice it's just a 1x squared. So I'll write my two sets of parentheses. X squared, the only possibility is x and x. What do we know about the signs? Once again, that last sign's a minus. So you're going to have 1 plus and 1 minus. 3. It doesn't get much nicer than that. There's only one possibility. 1 times 3. Now play it out in your head. The outer and inner. What sign should I put here in order to get back that positive 2x? I agree, the minus and the plus. And if you check it, the outer product is a 3x. The inner product is a minus 1x. 3 minus 1 sure gives us back that plus 2x. So we have x minus 1 equals 0, or x plus 3 is 0. So x equals, or negative 3. I agree. Okay, say it again. I could. Yes, it is. It's repetitive. That is right.
Equal positive, equal negative. Get a 0 and factor. Once again, notice how this stuff is building. Let's see. On Wednesday of the second week, that's when we first started this. Get a 0 and factor. Okay, everything builds. That's why you don't just jump in here. Okay. Now, you ready to...
Interval notation. Notice all we've solved so far this semester are equations. An equation has an equal to symbol. Must have an equal to symbol. An inequality has less thans or greater thans. So an inequality contains, well, there's actually 4 possibilities. Less than, greater than, less than or equal to, or greater than or equal to.
On Wednesday, we're going to solve inequalities. We're going to have a nice little recipe called the cut point method that will solve anything that has less thans or greater thans in it. But in order to do that, we got to assume y'all know something called interval notation. And you've seen it in some math class. It's not difficult, so we'll just review it right now.
Okay.
You want to?
The solution to an inequality is not just a number or numbers. With an equation, the solution is a number. It's 1 and -3 and -7 and 5. Okay? But the solution to an inequality, if there is a solution, is an interval on the number line. So what we're going to do is we're going to go through using this cut point recipe on Wednesday, and we're going to come up with a number line. We'll have a number line, and we'll have numbers labeled on the number line. These numbers that we're going to find on the number line are called cut points. And remember, with the number line, the smaller numbers have to be to the left. It goes small to big. So let's say this is something like -7, and then here's -1/2, and I'll say 3 and 4. I'm just randomly choosing. I chose a couple of negative and a couple of positive numbers, and some of those numbers are going to be, we'll go through and decide they'll be shaded. That means they're going to be included in the interval. Some of them won't be shaded. They'll be open circles. That means they're not included in the interval. For the sake of this example, I think I'm just going to alternate. Shaded, closed, open, closed, open. And then we're going to go through this little process. Some of these intervals we're going to wind up shading. That means the numbers satisfy the inequality. Other numbers, intervals, we're going to be crossing out. For the sake of this example, I'm just going to assume an alternating pattern. I'll say this is shaded. This one here is crossed out. This one is shaded. That one there is crossed out. And finally, this one over here is shaded.
In words, which regions are shaded red? Well, the first region is anything to the left of -7, including -7. Now, this middle region that's shaded red, that's all the numbers between -1/2 and +3, not including, open circles mean not including -1/2, including 3. And then finally, this final region over here, everything that's the shaded region are numbers to the right of 4, including or not including 4. Open circle means not including. Why don't we make a note of that? The closed circle means including. The open circle means not including.
Okay, that means including the cut point. An open circle means the number is excluded. I'll say excluded. It might be helpful for you as you're writing out this interval notation is to realize this arrow here, it's never going to stop. It starts going to the left and it keeps going forever and ever to the left. To indicate that abstract concept, you could think of that as going on to -infinity. It goes on forever to the left. Likewise, this arrow here, it's going to the right. It never stops. Those numbers are getting bigger and bigger. So to indicate that abstract concept, you could just put a positive infinity there. Or just an infinity. If you see an infinity without a sign, you assume it's a positive infinity.
There are no 8s out here. This is not -8.
It doesn't look like an 8.
Well, okay, but sometimes people think they're 8s.
Does that look like an 8? Maybe a sideways 8, but
I always tell my students it's not an 8.
that's great. Okay, here we go.
No.
For interval notation, you're going to be using symbols of grouping, either parentheses or brackets. Use a parenthesis if the number is excluded. Use a bracket if the cut point is included. So, and it has to go small to big. You start at the left. There's no end point. It's going forever. So you'll put a parenthesis, -8, and a
Infinity,
comma. Oh,
not
pardon me.
8.
Parenthesis, -infinity. You're the one that's got that 8 in my head, Tony. I never would have even considered that. -infinity, comma. The right-hand endpoint is 7. 7 is being included, -7. So we're going to put a bracket. You use brackets at closed circles. Anywhere else, you use a parenthesis. So all the numbers to the left of -7, including -7, or we can use the numbers between -1/2 and +3. This is a symbolized, a stylized U. It's red for set union, but that symbol, that U, is going to come from the toolbar. Because you're going to be typing in those intervals at the end once you're through with the problem. Now, let's look at the second shaded interval. It starts off with an open circle. That's a parenthesis. The left-hand endpoint is -1/2, comma. The right-hand endpoint is a 3. It's another shaded circle, so we'll put another bracket. Or, that set union from the toolbar. I look here. The interval, or you have to go small to big. The left-hand endpoint is a 4. The right-hand endpoint, that's a +infinity. What's going to go in front of the 4? Parenthesis, 4, comma, infinity. No. Always, we're going to have a little handout for y'all that summarizes the cut point process. And one thing that it says is that you only use rectangular brackets at closed circles. Only use rectangular brackets at closed circles. Anywhere else, open dots or infinities or negative infinities, you'll be using a parenthesis. So, open circles, infinity, negative infinity, use a parenthesis.
Because it wouldn't make sense to talk about including negative infinity. Negative infinity is just what we're using to represent this arrow. It wouldn't make sense to talk about including this arrowhead here, okay? So, in words, this is everything between negative infinity and -7, not including negative infinity, but including -7. Everything between -1/2 and +3, not including -1/2, but including 3. And what about this last interval? Everything between from 4 to infinity, not including 4 and not including infinity. It just doesn't make sense to talk about including infinity. Okay? You don't see this sort of number, parentheses, brackets before. You had to at some point in some math class. It's easy to forget. It's nothing really difficult. So,
but you're right. It is easy to forget.
The easier something is to learn, the easier it is to forget. Have y'all figured that out?
Okay, and how about, let's say, closed, open, closed.
Got to have a read some of it shaded. So.
Yeah. I'm just going to assume an alternating pattern.
So you're shading everything between -3 and +4.
I'll cross out there. I'm going to shade here.
How would we write the interval notation?
Keep in mind, we're going to go through this little cut point recipe on Wednesday, and this will be the last step. You'll go through and you'll build up this little number line. You'll figure out what numbers go on it. You're going to figure out whether to shade or cross out the intervals. The last step, you're going to have a number line like this. You got to express it using interval notation. So here's my first question. Will I be writing an interval with the negative infinity? No, because it's not shaded. That interval isn't shaded. Let's look at this one. Remember, it goes small to big. Interval notation has to go small to big. The left-hand endpoint is a -3. What am I going to put in front of that -3? Parenthesis or bracket? Bracket, because it's shaded. Comma. The right-hand endpoint is a 4. What's going to go after the 4? Parenthesis. Union. Okay, I'm going to let y'all call this interval out here to me. Keep in mind, what's way out here? Infinity? Okay, so y'all call it out to me. I'm going to, first of all, I type the bracket. 9/2, comma, infinity, and what goes after the infinity? A parenthesis. Always use a parenthesis with an infinity or a negative infinity. Always use a parenthesis with an open circle. The only time you use brackets is if you have a closed circle. And I have one more I want to do. Okay. Let's see. And I think I'll go close, closed, open, open. There'll be we'll have a little process we use to decide whether to put open circles or closed circles at the cut points. That'll be part of that cut point process. And I think I'm going to go cross, shade, cross, shade, cross. And you'll go through the little process. You'll come up with a number line like this. And now you're ready to, you have to type in that interval notation. You're going to have to type this stuff in, okay? So there'll be an infinity hot button for you. There isn't a negative infinity hot button. If you want to type negative infinity, you got to type the negative from your keyboard and then the little infinity symbol. But would you be typing infinity or negative infinity for this answer here? No, there's no negative infinity, no positive infinity. Y'all call it out as if you were typing it in. What's the first thing I'm going to write here? It's the first thing I'd have to type. Bracket, I agree. -5, comma. Oh, and you'll have to type the comma also. -3. What's going to go after the -3? Another bracket. Union, parentheses, because it's an open circle. The left-hand endpoint is, comma. Some terminology. An interval that has brackets on both sides is called a closed interval. Well, why is it called a closed interval? Because both of the endpoints are closed in circles. So that's a closed interval. What do you think we call this interval? Open interval. That's right.
Hey,
So if you hear us talking about closed or open intervals, there it is.
here's what we'll give y'all a copy of it on Wednesday. but it's under files on Canvas.
It is?
I think so.
Okay, I think it is.
I think it is. If not, we'll make sure.
We'll make sure it is
we'll
by
give you a
Wednesday.
copy.
But
See, it's a little. We're gonna have stuff that has less thans and greater thans. Step 1 tells you how to find what's called the solution cut points, and it tells you how to do an open or closed circle. Then step 2 tells you how to find something called the denominator cut points. Those are always open circle. Step 3, you draw the number line. Step 4 tells you how to shade. What I wanted to look at was here's step 5.
use a square bracket for closed circles. Use parentheses for open circles. Always use parentheses for infinities or negative infinities.
So if you do steps 1, 2, 3, 4 correctly, you're going to have that.
A number line like this.
Mm-hmm.
I think there's only a couple of problems where there are actually 4 cut points. I think there's only a couple of problems where there are 4 cut points, okay?
Usually it's just 2 or 3.
Usually it's just 2 or 3.
Mm-hmm. But
Okay. Any questions? I promised y'all easier class today than on Wednesday, so hopefully I kept that promise. Any questions? This is the earliest we've gotten out this semester. It's the shortest video this semester too, isn't it? So I'm going to cut it off.